Hello, I'm Darren Jackal. I'm in my studio. I talk about product development, design, and mountaineering. Welcome to another edition of Experimental Design, Discourse, and Disclosure. Just to review, I want to talk a little bit about the lamp and why I've decided to use it as an example for this discussion on design and the design process. First of all, a product like this is sort of a universal type of object where it's not specialized, that requires an informed user. This should be something that is usable by anybody, the public. It's also a failed product, so in my opinion, so we can talk about that as a case study, as an example. And I'll just need to give a little bit more review on where this came from. So it originally was a wall sconce in a nightclub, and it had some specific reasons why we were working on that. And so first was that this lighting needed to provide enough lumens for navigation. You needed to see where you were going. Two, we wanted the light to provide an atmosphere. We were looking for a mood. So we wanted it to be inviting and comfortable. And you'll see a lot of the proportions and the size comes from a desire to make them friendly, if you will. The third thing that we all wanted to do as designers is we wanted to provide the best lighting for people in terms of direct overhead lighting is pretty harsh, gives shadows, and shows off your bald spot, all kinds of unpleasant effects from that type of lighting. So it needs to be diffused or it needs to be reflected. So those are sort of the basis for what we were going for, and you'll see I'm going to switch over to the slides and we'll look at we'll start to get into where this idea came from. We'll talk about the design process and how things led to where ultimately they were, because I have some slides of the early work and I do remember quite a bit of what I was doing. So we'll get into that next. Stay tuned. So this nightclub was a pretty cool space. It had a main floor, which was an old warehouse space, you can see here, where we had the main bar. But it also came with a rooftop patio and a huge basement that was basically created by piercing walls and the floor plate in a few places. And what that led us to was these really kind of interesting spaces that were kind of hidden away. And so what we needed to do is we needed to attract people down to these places, and we needed them to feel comfortable in those spaces and feel like they were looking good in those spaces. So here you can see the wall sconces. The position of them was not up to us all the time because of existing light fixtures. We were just basically replacing them. Someone else was actually doing the diffusers, so we were just looking for kind of the shape and the size, the proportion, the form. So I'm going to talk about what I'll talk about next is one of the principles I use or I came across when I'm making things. And if you're somebody like myself who is a design builder, what you probably should do, or what I found was to be super helpful, was to just work with materials directly. Now there's quite a number of different principles or design directions or methods that I use in my creation of form. But we need to start somewhere, so I'm going to start with what I called scale back in my thesis times. And so I'm just going to read a little bit about this. Another important concept and directly associated with scale is the notion of dimensions. Used by topologists to discuss shapes, it offers a different way of viewing time and space. Euclidean measurements of length, width, and depth often fail to capture the essence of irregular shapes, and the idea of dimensions offers a different approach. The world we live in has 3 dimensions, and 3 numbers are required to specify a point in space, such as latitude, longitude, and altitude. The three dimensions are imagined as directions at right angles to one another. This is still the legacy of Euclidean geometry, where space has three dimensions, a plane has two dimensions, a line has one, and a point has zero. These Euclidean abstractions allow discussions of objects in meaningful ways. Gleick suggests that a roadmap, for all practical purposes, may be seen as a two-dimensional thing. Certainly in reality, the map is three-dimensional, but the thickness is minute and so unnecessary to its function that it may be disregarded. Then, thinking like this, what is the dimension of a ball of twine? Mandelbrot suggests that it depends on your point of view. From a great distance, the ball may be seen as a point in space with no dimension. A closer view reveals the ball to be spherical and therefore three-dimensional. An even closer view will bring the twine itself into view, effectively one-dimensional, although its tangled orientation makes use of three-dimensional space. The effective dimensions of twine begs the question, what about in between? Surely there is no clear boundary at which a ball of twine changes from a three-dimensional to a one-dimensional object. To this charge, Mandelbrot moved beyond dimensions of 1, 2, 3 to the seemingly impossibility of fractional dimensions. This becomes a useful approach to measuring qualities that have no clear definition, such as surface roughness, brokenness, or irregularity. So, to finish off, it is not the intention of the authors to embrace the concept of fractional dimensions in a strict sense as a topologist. The intention is to show that there are other ways of seeing our world, and these alternate views may offer the designer useful insights. I'm going to talk about the variation side of the design process. Generally, there are three basic ways in which to generate form. First off is the subtractive method, where you're removing material to create something. The second would be an additive process. This is 3D printed, and I create something by adding material to it. The third is the transformative process, and I don't add or subtract anything to my material, but I can change its properties by simply adding force to it somehow. So I can bend this piece of paper and I can change its form. I can also do something like crease it, which would alter its properties quite a bit. So we're going to use these basic concepts for generating form, as most products are assemblies of other components to create the final product. Subtractive, additive, and transformative. And then we're going to look at what we were talking about before with effective dimensions, where we are going to be working with things like lines and creating new shapes or forms from them, more and more complex. So this is an example of a single dimensional component that I can make occupy three-dimensional space with a variety of curves. So this is we're gonna introduce the concept of information pretty soon, and that's going to become an important element to talk about. So we're going to take other things like the effective dimension of a plane, and because one of the requirements of our lighting product is to encapsulate the light bulb or the light source, I was just using very simple two-dimensional planes to try and create forms that would do that, so we could diffuse it and direct it or reflect it. So when you add those two very simple concepts together, a single dimensional line with a two-dimensional plane, you would start to get even, more complex forms from that. So when I was making these mock-ups for the lamp, I was just generally taking styrene and altering the angles and a few other things to create what we thought were pleasing forms. So proportionally, these would be around the size and dimensions of the human skull. We wanted these things to be very warm and glowing. So that was sort of the idea. And from that wall sconce, I started developing the floor lamp. And the next phase is when we'll talk about how the concept came to me from a couple of very simple ideas, a paper clip and some popsicle sticks, and we'll talk about that next. All right, I'm going to wrap it up here. This is around the 10-minute mark, and that's sort of the length of time I like to make these episodes. So just quick review. In the past, we've talked about design as both a noun and a verb. Well, I've made the connection for myself between design and evolution. This includes things like variation and selection. I've also mentioned that I believe intelligence and evolution are two sides of the same coin. I mentioned seeing and how I want to see the world in as many different ways as I can. Things like body extensions from Marshall McLuhan, cybernetics, and self-organizing systems by Norbert Wiener, fractal dimensions or fractals by both Mandelbrot and Gleich. I spoke about innovation emerging from iteration. This comes from the Eameses. The idea of emergence is an interesting one. We'll talk about that later. I've also just touched upon briefly about the concept of information. I'll get a little bit more into this concept later on. And finally, just to wrap it up for now, there was Dieter Röhm's 10 Principles of Good Design. We'll refer back to that here and there, just to sort of give us a framework of where we want to go with things. That's it. Thanks for coming by. This has been Experimental Design, Discourse, and Disclosure. I'm Darren Jackal. I'm in my studio. I talk about design, product development, and mountaineering. We'll see you next time.